Good evening all. Am I audible? Hello.
Yes, ma'am.
Okay. So today we are going to start with unit number 8, that is lattices and Boolean algebra. So first of all we will see syllabus. In this chapter we are going to cover these points. Lattice as coset. So I think in unit number 4 we have seen what is coset. That is in relation. So coset is partially ordered set. Already we have seen what is partially ordered set. Then we have to see what is the definition for lattice, examples of lattice and its properties, then special lattices, Boolean algebra, definitions and examples, and Boolean functions. So this chapter covers two main parts. First one is for lattice and second one is for Boolean algebra.
Hello, ma'am.
Hello?
Screen is
Hello?
not visible, ma'am. Screen is not visible.
Okay. Yes, I will share it. Now check it. Is it visible?
Yes, ma'am. Yes.
Okay. So here we have to see lattice and Boolean algebra. So its properties, examples. Okay, so first of all we will see what is definition for lattice. So here point is given as lattice as partially ordered set or lattice as coset. So can anybody tell me what is coset? We have covered this point in unit number 4. So before that, just tell me what is partially ordered relation. POR, partially ordered relation. What properties it should satisfy? We have seen equivalence relation must satisfy properties RST, that is reflexive, symmetric, and transitive. So likewise, partially ordered set, that is coset, must satisfy three properties. That is, what are those properties? Have you remembered? A partially ordered relation. So partially ordered relation, a relation that satisfies three properties RAT, that is reflexive, antisymmetric, and transitive, that is called as partially ordered relation. And if you apply that relation on any set, then that set is called as partially ordered set. Okay. So lattice is a partially ordered set and that is represented here as L comma partially ordered relation. So L is a lattice and this is a partially ordered relation in which every pair of elements A comma B belongs to L has a greatest lower bound and least upper bound. So here two different terms are related with lattice and those are greatest lower bound, that is GLB, greatest lower bound, and least upper bound, that is LUB, least upper bound. Okay. So we will revise it. A lattice is a partially ordered set in which every pair of elements, if you consider any two elements, A comma B, for those two elements, there should be greatest lower bond and least upper bond. So this is the definition for lattice. Now, the greatest lower bond of a subset A comma B belongs to that is subset of L will be denoted by A star B. In short, if you consider any two elements and if you want to define greatest lower bond, then this is the symbol that is star to represent greatest lower bond. So, greatest lower bond for these two elements A and B, it is given by A star B. So, what is meaning of this A star B? Greatest lower bond of elements A and B. And least upper bond is given by A XOR B. So, again, this least upper bond is represented by this symbol XOR, and this is for two elements A and B. That's why least upper bond of these two elements is represented as A XOR B. So here they have given that symbolical representation. The greatest lower bond of A and B, that is equals to A star B. Because here we have seen the greatest lower bond is represented by this star symbol. That's why greatest lower bond of A and B, that is equals to A star B. The mean or product of A and B. So this star operation is also called as meet operation or product operation of A and B. So likewise, least upper bond of these two elements A and B, this is equals to A XOR B. And this operation is also called as join operation or sum operation of A and B. So just you have to remember the greatest lower bond is represented by star operation, and that operation is also called as meet or product of those two elements. And least upper bond is represented by symbol XOR, and this is represented as either join or sum. Other symbols such as this is symbol for AND or conjunction, and this is for disjunction or OR. So this AND is associated with star operation, that is meet operation, and OR is associated with this XOR operation, or we can say least upper bond. Again, two symbols are there, that is dot and plus. So these are different symbols used to represent greatest lower bond and least upper bond. Okay. So just you have to remember what are the alternative symbols are there to represent these two operations. First, keep in mind that greatest lower bond of any two elements is A star B. So again, this star can be meet or product of A and B. Again, this star operation can be replaced by AND operation or dot operation. Okay. So these are three different alternative symbols. First operation, एकतर star symbol तुम्ही use करू शकता, or you can use this AND symbol or dot symbol. So likewise for least upper bond, you can use XOR operation or OR operation or plus operation. Just they have given alternative symbols. Have you understood? Okay. We will take one example. From that you will get idea about what is greatest lower bond and least upper bond. Okay. So if you consider this diagram, first diagram, here it is containing two elements. Okay, this is first element, this is second element, and these two elements are connected by line. So now we have to check whether this one is lattice or not. What we have seen in definition, if a lattice is having greatest lower bond and least upper bond, then that is a lattice. Now here, if you observe this first diagram, here we can say that this one is a greatest lower bond. जो सगळ्यात खालच्या साईडला आहे तो काय असणार आहे greatest lower bond and this element is a least upper bond. Okay. जर chain असेल, chain means if elements are connected in line, then lowest element will represent greatest lower bond and upper element will represent least upper bond. So, if you consider these two elements as A and B, then this A is a greatest lower bond and B is a least upper bond. Okay. So, likewise, if you consider second diagram, here four elements are there. Consider the names of these elements as A, B, C, D. Now, if you want to check whether this one is lattice or not, then again we have to check whether it is having greatest lower bond and least upper bond. Now, what is the greatest lower bond for these two elements, B and C? Again, it is A, and least upper bond is D. So, we can say that here greatest lower bond and least upper bond exist for these two diagrams. That's why these are lattices. So, here I have given some examples. From that you will get idea what is lattice and how to recognize whether a given diagram is lattice or not. Okay. So first we will see how to check for greatest lower bond and least upper bond. Okay. So here some diagrams are given and from that we have to recognize greatest lower bond and least upper bond. Now consider first diagram, same as that we have seen. So this diagram is containing two elements A and B. So A is called as greatest lower bond of elements A and B. So if you apply greatest lower bond operation on A and B, it is A. So its answer is A. That's right. Greatest lower bond of A and B is equal to A. So what is meaning of this greatest lower bond? जे काय सगळ्यात खालच्या साईडला जो असेल तो म्हणजे असणार आहे greatest lower bond. And least upper bond means what? The element which is placed at upper side. Okay. So here B is placed at upper side. That's why least upper bond of these two elements A and B is B. So again we have seen what is the operation for least upper bond, and that operation is a XOR operation. So A XOR B, that is equals to B. So in this way we have represented greatest lower bond and least upper bond for first diagram. So first of all tell me, have we understood this concept? Hello? Concept समजली का?
Yes, ma'am.
Okay. Now consider second diagram. So here four elements are there, A, B, C, D, and all these elements are connected by line. That's why greatest lower bond means what? The element which is placed at lower side, and that element is A. So for this diagram, greatest lower bond is A and least upper bond is D. Okay. Now consider third diagram. So can we find greatest lower bond for this diagram? Consider elements A and B. Okay. So for these two elements, we have to find greatest lower bond and least upper bond. Now check whether A and B are meeting at any point. No. So here greatest lower bond is missing. That's why A star B I have given as question mark because that element is not present here. But it is containing least upper bond, and least upper bond of these two elements A and B is A XOR B, and that element is C. So here we can say that this third diagram is not a lattice. Why? Because greatest lower bond is missing here. Are you getting this? How to recognize whether given diagram is lattice or not?
Yes, ma'am.
Okay, good. Now check for fourth diagram. So here again for each and every pair of elements we have to check whether there is greatest lower bond and least upper bond. Now check for elements B and E. Sorry, B and C. So for these two elements, the greatest lower bond, that is A, and least upper bond is E. Okay. So for this, we have find out both the elements. Up to this, it is fine. But if you observe the pair of elements A and B, okay. So here A XOR B is what least upper bond of these two elements is C. But greatest lower bond for A and B it is missing. That is A star B is missing. That's why I have written here question mark. So now you tell me whether this diagram is lattice or not. Lattice आहे का मुझे?
No.
No. Yes, because in order to be a lattice, it should have both the elements as greatest lower bond and least upper bond. But here one element is missing. That's why this diagram is not a lattice. Now check for fifth diagram whether this one is lattice.
No.
No, because here greatest lower bond of these two elements A and B it is present and that element is C. But if you check for least upper bond, that element is missing. That is A XOR B that is missing. That's why this diagram is not a lattice. Okay. So in this way we can check greatest lower bond and least upper bond. And if both the elements are there, then only we can say that that diagram is a lattice. Otherwise, it is not. So here I have written one statement. Lattice should have only one greatest lower bond and least upper bond. एकच पाहिजे. Greatest lower bond पण त्या diagram साठी एकच पाहिजे and least upper bond पण एकच पाहिजे. Diagram साठी नाही म्हणते. For that particular pair of elements. आता इथे आपण या diagram मध्ये कुठले कुठले pair consider केले? First pair B C and second pair A B. So likewise, if you consider DC, for this pair, there should be only one greatest lower bond and only one least upper bond. So if this condition is true for all the pair of elements, then only we can say that given diagram is lattice. Second question is given as which of the following are lattices? So from this we have to observe whether the diagram is lattice or not. Now consider first diagram. So in this diagram, four elements are there: A, B, C, D. Now what we have seen for every pair of elements, that प्रत्येक pair जर AB घेतली, AB. So this is one pair. So likewise, if for every pair of elements there exists greatest lower bond and least upper bond, then only that diagram is called as lattice. Now consider the first pair of elements from this diagram as AB. So can you tell me for this pair which one is greatest lower bond and which one is least upper bond? Yes. What is
A is greater.
yes, correct. A is greatest lower bond and B is least upper bond. So likewise, if you consider the pair of elements as B and C, then B is greatest lower bond, C is least upper bond. Again, again, if you consider pair of elements as C comma D, then C is a greatest lower bound and D is a least upper bound. So likewise, again, if you consider the pair of elements as A, D, then A is greatest lower bound and D is least upper bound. So here we can say that for every pair of elements, there is only one greatest lower bound and least upper bound. That's why this given diagram is lattice. Have we understood these points? Pramalika?
Yes, ma'am.
Okay. Now, check for a second diagram. So here in this diagram, four elements are there: A, B, C, D. Now, again, if you consider pair of elements AB, then greatest lower bound is A, least upper bound is B. If you consider AC, then greatest lower bound is A, least upper bound is C. So likewise, this can be done for every line, that is AB, AC, CD, BD, likewise. So here just we are going to check for the elements like B, C. So these two elements, those are not connected by direct line. That's why for this pair, we have to check whether there is greatest lower bound and least upper bound. So for this pair B comma C, the greatest lower bound is A because these two elements are meeting at one point and that point is A, and least upper bound is D. Okay. So this is a lattice because greatest lower bound and least upper bound exist for each and every pair of elements. Now check for next diagram. आता कुठले कुठले पेअर कन्सिडर करावे लागतील? जे स्ट्रेट लाईन मध्ये आहेत, सपोज जर बी कॉमा ई घेतलं तर ह्याचा ग्रेटेस्ट लोअर बॉन्ड बी असणार आहे, लीस्ट अपर बॉन्ड ई असणार आहे. जर तुम्ही ई डी घेतली पेअर तर अगेन ग्रेटेस्ट लोअर बॉन्ड इज बी, लीस्ट अपर बॉन्ड इज ई. So it is not required to check for greatest lower bound and least upper bound. For any two elements, those are connected by direct line. त्याच्यासाठी ऑलरेडी आहे. जे एलिमेंट कनेक्टेड नाही आहे डायरेक्टली त्यांच्यासाठी आपल्याला चेक करायचे. So if you consider this third diagram, we can consider pair of elements like B comma C, C comma D, and D comma D, because these three elements are not connected by direct line. Now observe first pair, that is B comma C. So what is the greatest lower bound for this pair of elements?
A.
A. And least upper bound?
E.
E. That's why B star C, greatest lower bound of B and C, that is equals to A, and least upper bound of B and C, that is B XOR C, that is equals to E. Now check for elements C comma D. So greatest lower bound for these two elements, it is A, and least upper bound
E.
E. Again, if you consider elements B and D, then greatest lower bound for these two elements, it is A, and least upper bound E. So again we can say that is there is greatest lower bound and least upper bound for every pair of elements. That's why this given diagram is lattice. Now check for fourth diagram. And tell me what are the different elements you are going to consider. We have to look for such elements, those are not connected by direct line.
ACAE.
Yes. First one is CD, we can take. Again, BD, we can take. So if you take CD, then greatest to lower one for C and D. Now check. These two elements are meeting at point A, which is lowest point. So greatest lower bond for these two elements is A. That is represented here as C star D. And least upper bond primary. Again, we have to check for upper element in which these two elements are meeting. So C and D, these are meeting at one single point, and that is E. That's why least upper bond of C and D, it is E. So likewise, check for pair of elements B, D. So B star D. So this answer for B star D, that is greatest lower bond of B and D. A. And least upper bond for B and D, it is E. Yes. So again we can say that here also there exists greatest lower bond and least upper bond for every pair of elements. So this is a lattice. Now check for next diagram. So first of all, tell me what are the elements we need to consider? What are the pair of elements?
CD, CE, BE, and BD.
D. Yes, correct. One is F. So again here both the elements are present. Then BE. So if you consider this pair BE, then for these two elements, greatest lower bond primary A and least upper bond is F. So again, if you consider pair of elements C and D, then greatest lower bond is A and least upper bond is F. So again, here the greatest lower bond and least upper bond exist for every pair of elements. So this given diagram is lattice. Now check for next diagram. You have to tell me whether this one is lattice or not. And tell me what are the pair of elements you are going to consider.
CE, CB, CD.
CE, CD and BD. So for these two elements CE, what is the greatest lower bond? Again you have to check. These two points C and E are meeting at lowest point and that point is D. Greatest lower bond. This what? जो element lower side ला आहे आणि त्यातला पण greatest पाहिजे. So again, we can say that C and E these are meeting at point A. बघा बरं, C and E. A मध्ये येतात का? ए पण आहे, बी पण आहे, पण आपल्या डेफिनेशन मध्ये काय ग्रेटेस्ट लोअर बॉन्ड म्हणजे लोअर पाहिजे आणि त्यातलं पण अप्पर साइडचं एलिमेंट. दॅट्स वाय आन्सर फॉर दिस ग्रेटेस्ट लोअर बॉन्ड ऑफ C and E is B. Now list upper bond for these two elements. It is F. So again we can consider another pair as C and D. So greatest lower bond for these two elements is A and least upper bond it is F. So just one pair is remaining, B and D. So for these two elements greatest lower bond is A and least upper bond is E. So this is a lattice. Now next diagram. Look at the diagram and tell me whether this one is lattice or not. Okay, so first of all tell me what are the pair of elements you are going to consider?
BD and CE.
Yes, BD and CE. Okay, so if you consider BD, okay, so for this, which one is greatest lower bond for B and D?
A.
A.
A. Yes, correct. And least upper bond?
C and E.
C and E.
Yes. B XOR D. So B and D, these are meeting at both points, that is in C and in E. In short, there exist two least upper bonds for B and D. So if you consider another pair of elements as C and E. So for this C and E, greatest lower bond is B as well as D, because C and E, these are meeting at point B and D, and least upper bond is F. So here we can say that there exist two elements or two greatest lower bond and least upper bond for this pair of elements. That's why this is not a lattice. Lattice साठी आपण definition काय बघितली? For every pair of elements, there should be only one greatest lower bond and least upper bond. Then only that diagram is called as lattice. But here, in case of this diagram, if you take B and D, so for these two elements, there exist two least upper bonds. So for this B and D, C and E, these are two least upper bonds. And if you consider the pair of elements C and E, then for this two greatest lower bonds are exist, and those are B and D. That's why this violates the property of lattice. So this is not a lattice. So in this way we can recognize whether given diagram is lattice or not. Have we understood this concept?
Yes, ma'am.
Okay. So here in this question, some sets are given. So let n be a positive integer and s of n be the set of all divisors of n. For example, if you take value for n as 6 Then S of 6 is equals to 1, 2, 3, 6. In short, here this set will include all the divisors of 6. So likewise, if you take n is equals to 24, then that set S24 will include all the divisors of 24, like 1, 2, 3, 6, 8, 12, and 24. And D denotes relation of division. Then we have to draw what are the lattices for S6, D. Means what? It should be a lattice and that should satisfy divides relation. Now, for this first lattice, we can check what are the elements of S6. So, S6 is containing elements as 1, 2, 3, 6, and that relation is divides relation. So, here this one is the first element and that is 1, then here it is 2, here it is 3, and this element is 6. So, this is a lattice for diagram S6. हे समजलं का? हा लॅटिस कसा ड्रॉ केला? Again, this is same as that of the Hasse diagram. In unit number 4, we have seen how to draw a Hasse diagram. ही diagram असेच का ड्रॉ केली समजले का? Yes.
Yes, ma'am.
Okay. Now, just you have to take these examples and you have to solve this one as follows. You have to draw lattice for S24, D, then S8, D, S30, D, where S24, S8, S30, these are the divisors of 24, 8 and 30 respectively, and D, this is the relation of division. So just we have seen how to draw lattice for this first S6, first set as S6. So likewise, you have to draw lattices for this remaining one. So try at home, and while coming to the next lecture, I think tomorrow we are having lecture. At that time, you have to show me how you have drawn the lattices for this diagram. Is it fine? Because we have already covered how to draw partially ordered set and Hasse diagram. So likewise, same way you have to use here and you have to draw lattice for this remaining set. Just at every time you have to observe whether for any two elements there is greatest lower bound and least upper bound. If both the elements are there, then only you can say that whatever lattice you have drawn, that is correct. Can you draw it?
Yes, ma'am.
Okay. Just try for it. If you are not able to draw, then I will explain. Okay. So today we will stop here. Just give me presently. Roll number 1.
Yes, ma'am.
2. Roll number 2. 3.
Yes, ma'am.
4.
Yes, ma'am.
5. 6. 7.
Present.
8. 9.
Yes, ma'am.
10.
Present, ma'am.
11.
Yes, ma'am.
12.
Yes, ma'am.
13.
Yes, ma'am.
14.
Yes, ma'am.
15.
Present.
16. 17,
Yes, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21, 22,
Present, ma'am.
23,
Present, ma'am.
24,
Present, ma'am.
25, 26, 27,
Present, ma'am.
28, 29, 30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34, 35, 36,
Present, ma'am.
37,
Yes, ma'am.
38,
Present, ma'am.
39,
Yes, ma'am.
40,
Present, ma'am.
41, 42, 43, 44,
Present, ma'am.
45, 46,
Yes, ma'am.
47, 48, 49, 50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, 55. Yes,
Yes, ma'am.
54 is present. Okay. 55,
Yes, ma'am.
56, 57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60, 61, 62, 63,
Present, ma'am.
64,
Present, ma'am.
65, 66,
Present, ma'am.
67,
Present, ma'am.
68,
Yes, ma'am.
69, 70, check for absent numbers.
Hello,
Yes?
ma'am. 40, 42 is present.
Okay. Roll number 2, 5, 6, 8, 16, 21, 26, 28.
Ma'am, 26.
Which one? 26.
26.
Okay. 28, 29, 41, 43, 45, 47, 48, 49, 52, 53, 56, 59, 60, 61, 62, 65, 69, and 70. Okay. So today we are going to stop here. Thank you.